So now we need to start to become a bit more precise. So what we said is that we know that demand is elastic if it changes more than proportionally. Yeah? So and what we're going to look at for the rest of this week is price elasticity demand. So let's imagine we've got two situations. One in which price goes up by 23%, and demand goes down by 45%. And a second case in which price goes up by 17%, and demand goes down by 38%. And what I want to ask you is, well, which do you think is the more responsive? Yeah? And which one's more elastic? Is it A, or is it B? And the answer is, intuitively you might go for A, but the answer is actually B, because if you look at what twice as much would be. So if demand had changed by twice as much as price, it would have fallen by 46%, but it's only fallen by 45%. Yeah, so that's just less than 2 times. Whereas here, a 17% rise in price has caused demand to fall by 38%, which is more than 2 times. So in fact, in relative terms, B is the more elastic. So what we need is and all we did to determine that is we compared the two. We said, well, how much does demand rise compared with the change in price? So what we need is a formula. And the formula actually is a very simple one because you just worked it out. We just worked it out intuitively. All we are doing is we're going to compare the percentage change in the quantity demanded. So those were the numbers on the right a minute ago. And we're going to divide that. We're going to compare it with the percentage change in price. And those were the numbers on the left. So we know that if something is elastic, we know that the demand is going to change by more than price. So if it's elastic, we get something like a 10% rise in price leads to a 15% fall in demand. Or we might get a 10% fall in demand leads to a 10% fall in price leads to a 20% rise in demand. Both of those are elastic. And the question is, well, how elastic? And the answer is, well, in this case, it's 1.5 times as much. Demand changes by 1.5 times as price changes, but they go in a different direction. So we put a minus sign here, not to show that demand has gone down, but to show that it goes in the opposite direction to price. The minus sign is a correlation. Here, demand changes by 2 times, twice as much as price, and again it goes in the opposite direction. So here demand's risen, but the sign is still minus, because the minus sign is a correlation. And a negative correlation means that an increase in one thing leads to a decrease in the other, or a decrease in one thing leads to an increase in the other. And what we can therefore see is that if it's elastic, we said that demand changes by more than price changes, therefore the top will always be bigger than the bottom. And therefore, what we know is that if price elasticity demand, we know that price elasticity demand for a situation that's elastic, for an elastic demand situation, is going to be a number like minus 1.1, or minus 1.5, or minus 2, or minus 3. The number is going to be bigger than 1. So if it's elastic, then what we know is that for an elastic situation, this is going to give an answer between minus 1 and minus infinity. So sometimes we say more than 1, but that can be a bit confusing because mathematicians go, well, more than minus 1 is naught. Naught is more than minus 1. So all we mean is that the actual number itself is bigger than 1. Yeah? So any number between minus 1 and minus infinity means that demand has changed by, if we said it was minus 2, demand has changed by 2 times as much. And although you'll never see it in textbooks, for some reason, the secret unit of elasticity, there is a secret unit of elasticity, which is the number of times. Elasticity, if we say PED is minus 2, all that means is that demand changes by 2 times as much as the change in price. So what about inelastic? Well, inelastic is just the reverse. It's very simple. Again, we're saying that we're going to compare the percentage change in quantity demanded with the percentage change in price. And all we're going to say is, well, suppose that price goes up by 10%. If demand's inelastic, demand will fall by less than proportional, like 5%. Yeah, or if price goes down by 20%, demand will change. Yeah, in this case it will rise because demand curve sloped downwards. Yeah, we know that a fall in price will cause a rise in demand, but by less than 20%, say 15%. So how elastic is it? Which is the more elastic situation? I mean, they're both inelastic, but which one, but how inelastic are they? In this case, 5 divided by 10 is a half. What we know is that demand changes by 0.5 times as much as price, and in the opposite direction. So it's a negative correlation. Here, we know that 15 divided by 20 is 0.75. Demand changes by 0.75 times as much as price changes, and in the opposite direction. So, except in very unusual circumstances, all price elasticity demand are negative. And what we know is that if it's somewhere between, for price elasticity demand, if it's between 0 and -1, then that's inelastic. Demand has changed less than proportionally. If it's -1 to -infinity, then that's elastic. And demand has changed more than proportionally. But it would also be true if we had some sort of weird situation where a rise in price led to a rise in demand. So it would also be the case that if it was 0 to +1, it would still be inelastic. It would be very weird, but it would be inelastic. So anywhere between -1 and +1 is inelastic because it's changing less than proportionally. And likewise, if it was between +1 and +infinity, it would be elastic. But those are very unusual. You'll never come across those. But we will for the other elasticities, because we know with income, when income goes up, demand's most likely to rise. If people have more money, they're more likely to spend it. And that's when your plus elasticities become important. But for price elasticity demand, what you're going to see is this. If elasticity is between 0 and -1, that's inelastic. It's changing less than proportionally. -1 to -infinity, that's elastic, changing more than proportionally. If it's precisely -1, then that's sometimes called unitary elasticity. Sorry, you won't be able to read that properly, sorry. It's called unitary elasticity. And all that means is that the percentage change in demand equals the percentage change in price. So they cancel one another out. If price goes up by 10%, then demand goes down by 10%. If price goes down by 5%, then demand goes up by 5%. And that's what unitary elasticity means. It's quite unusual to find that. It's a bit of a coincidence, but it's neither elastic nor inelastic, so it has its own name, which is unitary. The formula gives us actually three pieces of information. If I tell you that price elasticity demand is -2, then that actually tells you three things. Firstly, it tells you that there is a negative correlation. And what that means is that an increase in price is going to lead to a decrease in demand, and a decrease in price is going to lead to an increase in demand. It's also 2. It's also more than 1. 2 is more than 1, ignoring the sign. Therefore, it's changed more than proportionally. Demand changes more than proportionally. And therefore, this is an elastic situation. It's elastic. But the most important thing is the secret unit of elasticity times. What we know is that demand changes 2 times, twice as much, 2 times as much as price changes. So if we see that, then what we know, if we see an elasticity of -2, we know that demand changes by 2 times as much as price. That because it changes more than proportionally, it's elastic, and that demand goes in the opposite direction to price. And that's what the formula tells you.